work for my presentation. Okay, what I want to see, double check, I tried this the other day and it worked. If I can write on here and it stays, yay, it does. I have to erase it that way right now. Okay, so I can write on that. I just have to convert my PowerPoints into keynotes. So if you are looking at one of the slideshows on that I put on Backpack, I don't know if you'll be able to tell maybe by the end of it whether it's a PowerPoint or a keynote, but you could open it in Keynote and then it will go more normal. I noticed some of the times that in Backpack it's got some weird symbols or things are on top of each other. You might have to open it up in PowerPoint or in Keynote now in order to get it to look right. So we'll see if that works for us. So what we're going to do today is try and prove lines parallel. So remember what a converse was. We did converse, inverse, contrapositive. What was a converse? Let's see, iPad's going to face here. If Q, P. Okay, if Q, then P. So what did we do from the original if-then statement to create that converse? This is what do we do on the converse then? What Kiernan reminded us of is if Q, then P. So it doesn't have the not part in it. It's not any negating. All we are doing is switching the hypothesis and the conclusion. Okay, and when we talked about things that were logically equivalent, the converse was not logically equivalent to the original statement. So just because we have a statement Friday that was true doesn't mean when we look at the converse of it today that that's going to be true. So we're going to investigate a little bit to see if it's true or not. And if it is, then we'll have a certain theorem that is just that one with the title converse of whatever it was. This is 54, I made this one 54, and I think from where I was standing, it looked like these were parallel. So what did I begin with? Didn't I make angle 1 congruent to angle 2? We'll say that was angle 1 and angle 2. Then what did I conclude? The lines are parallel. My conclusion is that the lines are parallel. That's not what I started with. So it's completely backwards from what we did on Friday. If you put it all in one picture, you can't tell what comes first and what comes second. So if angle 1 have the angles as your hypothesis, the parallel lines as the conclusion. The converses have the parallel lines as the conclusion. All right, so let's try, and that was to emphasize that also. What's the hypothesis, what's the conclusion? Here's a problem related to it, kind of a simple problem. I'm telling you that the measure of angle 1 and the measure of angle 3 are the same. And you are supposed to show, which is kind of an easier way to say prove, show me or prove to me that line L is parallel to M. Now, do you have something that concludes two lines parallel? Look at your notes, what you just finished writing. The conclusion there is then the lines are parallel. What's it say the hypothesis is? Or what did you draw a picture of if you understood what you drew? What's the hypothesis? If what? Vanessa, what's it say? Up at the top there, the corresponding angle. Converse.
If two congruent lines are cut by transversal so that a pair of corresponding angles are congruent.
Okay, that much is the hypothesis. When you get to the word then, your hypothesis is done. Okay, so do I have two coplanar lines cut by a transversal? Yeah, L and M are the two lines, and T, we'll say, is the transversal. Okay, so that a pair of corresponding angles are congruent. Does this say the angles are congruent? No, but can we get there from this? Yeah. Okay, so we can get angle 1 congruent to angle 3, and then we can use that converse to come up with the conclusion about the lines parallel. So what are the steps we would need in this sequence? Well, we're given that the measure of angle 1 is equal to the measure of angle 3. Can we get from there to angle 1 congruent to angle 3? We did some proofs and coming up with looking at some and giving reasons last chapter. What can we use to get the line, or to get angle 1 congruent to angle 3? What comes up with congruent angles? What are congruent angles? Let's think through their definition. Connor, what are congruent angles?
Two angles about the same measure.
Okay, I have two angles with the same measure. So I can say they're congruent because of definition of congruent angles. Why did I have to do that? Well, the Converse theorem that Vanessa read the hypothesis of said we need the corresponding angles congruent, not equal, congruent. So we got them congruent. So now what can we conclude based on what she started to reading? I'll let you read the then part now. What's the conclusion?
Then the two lines are parallel.
So what can I conclude? L is parallel to M, and what's the reason? Converse of the corresponding angle postulate. It's kind of like a little proof here. Maybe we should set it up more formally with our steps so we know what's going on. So we were given that these two were equal. We converted that into congruent because that's what the hypothesis says on that converse that we were trying to use to conclude the lines are parallel. Okay, ask me questions. Okay, let's go on then. Here's a little bit different one. Use the given information again to show that the lines are parallel. So let's see what they gave us. They gave us something about angle 3 and angle 7. And then they told us that x is 30. As you look at the picture, 3 and 7, do you notice those are corresponding angles? So if we can get them congruent, we can use that same converse that Vanessa read to conclude the lines are parallel. So can we get those two angles congruent? What would we do with that given information? On this one, we're going to substitute. Remember what substitution was? Substitution. Put the 30 in there. Put the 30 in there. So I substituted, and then I finished calculating. So I got 40 degrees for angle 3, 40 degrees for angle 7. So what do you notice from calculating each of those being 40? They're the same, right? So let's say they're the same. How can I say measure of angle 3 equals measure of angle 7? I've got measure of angle 3 equals 40. Measure of 7 equals 40. Can we take out this 40 and put something else that's equal to it in its place? Measure of angle 7. What's our reason? Take it out and put something else in its place. Substitution. Okay. So substitution, property of equality. I took out that 40 and put measure of angle 7 in its place. Think about that last proof that we did, last sample. What should I do next? After the measures were equal, definition of congruent angles, correct? Then, we have corresponding angles that are congruent right now. So then, what can we conclude?
The two lines are parallel.
Okay, so L is parallel to M because of, what's the one saying, what's the title of what you've been reading?
Converse of the corresponding angles postulate.
Okay, so that's how we get the lines parallel. Give me a thumbs up or down. Is it making sense? Okay, some of you aren't showing. If you're not showing me, I'm thinking that that probably means, I don't know. So what line can I help explain? Any certain line? So what we did was we took the given, we put the 30s in there and calculated. Maybe it's this step right here. So let's just kind of summarize. Let me put it like a flow chart. We had measure of angle 3 equals 40 degrees. Measure of angle 7 equals 40 degrees. And putting those two together, we get measure of angle 3 equals measure of angle 7. What did we do? We took this one, but we took out the 40, and in its place, since 40 and angle 7 are equal, we replaced it. So that's the substitution that was done. Anything else? And is that the part that got stuck on, or no? Yeah? Vanessa, question? No? Okay, let's go to the actual construction. Now, what I had you do earlier was with the protractor. Okay, the parallel postulate is actually what guarantees that there is a parallel that you can create. So the parallel postulate says through a point that's not on a line, notice I've got the line and the point P that's not on it, it says there is exactly one line parallel to L that goes through that point. So there is such a line and there's only one. So as far as a picture to go with the parallel postulate, start with a line and a point that's not on it. This parallel postulate says there is such a line that you can make. There is such a line parallel to that line that goes specifically through point P. And we just constructed it using corresponding angle converse. So we're making parallel lines today, creating parallels. Okay. Flip to the back and you'll see there are 3 more ways to get lines parallel. They are the converses. They are the converses of the alternate interior angle theorem, alternate exterior angle theorem. Is it the meaning of the word? The meaning of the word means it's a definition. So you would use definition of supplements, and then you can do this converse to get some lines parallel. Got your notes down, it looks like? Let's try some example ideas. Okay, this is just simply asking you to name the postulate or the theorem that would prove line P parallel to R. Okay, why don't you, Ben, what'd you have? Correct. Converse of alternate interior angle theorem. Number 2, Kelsey?
Converse of alternate exterior angle theorem.
Correct. Number 3, Jake. Not on 3. 3, they're not same side interior, because I would agree they're on the same side, but 7's not an interior angle, it's an exterior. So which converse should he have on that one, Grant? Did you get to number 3? Yes. Correct. And then the last one, Anthony? Correct. Questions about those? Okay, so how would, this is like what we did just a little bit ago. How would you prove that R and S are parallel? If I tell you that angle 4 is congruent to 8. Don't have to do a whole lot with this one. Knowing what you're given, and Kate, what do you think? What's the reason that the lines would be parallel? Correct. So this one really is just 2 things. You have to put down what you're given, and then just that converse supports the lines parallel. One of the shortest proofs that you can do. If you want to get in the habit, because of this chapter, putting it in a formal proof, I'm doing it a little less formal because it just says show. But if you want to practice what we're gonna be doing next chapter anyway, number the lines, put your 2 columns, that's basically what you're doing anyway. You know, we did one like this earlier. What did we need to do to get to the things? I think this one's actually a little bit different. So after the given information, what are we going to do next? Okay, after the given, what are we gonna do as a second step? Taylor, get an idea? Think what we did earlier? Okay, plug in, so you're substituting, put the 5 in there. And I think when we did that before, looking at what I still have on the board, we got the angles to be the same. But this time, we have one angle 58 and one angle 122, they're not the same. Let's look at the picture, angle 2 and angle 3, what might we try? You recognize 58 and 122 would add up to be 180. So instead of substituting to show they're equal, this one we're going to add together. So I'm going to do addition property of equality. On the left side, it's just going to show the symbols. Angle 2, measure of angle 2 plus measure of angle 3. On the right side, it's showing that I'm adding 58 and 122. Then I'm going to simplify it, 180. So Jacob, what do I know about angle 2 and 3 now? What can they be called? Supplementary, by definition of supplementary angles. And then I have angle 2 and angle 3 supplementary. Look at the picture. Angle 2 and angle 3 are what kind of angles, Michael? Are they corresponding or what?
Same side.
Okay, so we have same side interior angles that are supplementary, so what can we conclude? We can get the lines parallel by converse of same side interior angles there. So it's like a step-by-step proof, that's what you're kind of doing. All right, let me skip through a couple examples, get to, here's an actual proof. We'll see if we can put some thoughts together and then spend whatever time we have left on an assignment. P and R are parallel. Angle 1's congruent to 3. How can we prove that L and M are parallel? Okay, let me start you out. P parallel to R. That's given. I'm making it look formal because it actually is set up in that way. Statements over here, reason here. Okay, and I'm gonna highlight. Right now I know line P is parallel to line R. They've got some angles numbered in the picture. You can decide, should I use L as the transversal? Should I use M as the transversal? Or are they kind of leading us because of where they numbered things? Let's ignore the L as the transversal. So if P and R are now parallel, what angles are congruent and why? This was Friday. These lines are parallel. So what angles are congruent and why? Help me out, Zach. Okay, does the converse, look in the conclusion part of the converse. That should be in your notes of today. Does the conclusion have angles congruent? The conclusion column has lines parallel, right? It's not the converse. It's the one we did Friday, okay? So by the alternate exterior angle theorem. So Zach helped me get angle 2 congruent to angle 3. Line 3. Angle 1's congruent to angle 3. Where'd I get that from? It's given. One's congruent to 3. Well, 3 is already marked this way. So if I mark 1, it's going to be this way. And if I do that, I notice not only is 1 congruent to 3, but isn't 1 congruent to 2? Okay, let's look at what we've got written up here. Can I get 1 congruent to 2? I could, if this were switched around. Let's switch that around. Let's make it angle 3 congruent to angle 2. What allows me to switch it around? Symmetric property of equality, no, congruence. Okay, now what I want you to look at is lines 3 and 4. If angle 1 is congruent to 3, and angle 3 is congruent to angle 2, why is angle 1 congruent to angle 2? Anthony? Good. Transitive property. We say of congruence. Now, why is that helpful? Okay, well, focus now on angle 2 being congruent to or 1 congruent to angle 2. Why would that make this line parallel to this one? You're really ignoring this part of the picture. If 1 and 2 are congruent, why are the lines parallel? Because what? Okay, can you give me a theorem? I'm looking for a theorem or postulate that concludes why these lines are parallel. You had 3 on one page and 1 before it. There's 4 things we can use today to get lines parallel. Do you know which one, Michael?
Converse of corresponding angles postulate.
Corresponding angles postulate. Did you say converse or not?
Converse.
Okay, converse, right. Those are the corresponding angles that are congruent. So we can conclude line L parallels to M because, as he said, the converse of the corresponding angle postulate. That's how you would do a proof involving it. And if you don't have anything in your notes, this might be one to get down if you didn't do that. So what you're going to be doing on your assignment will be coming up with if the lines are parallel and why they're parallel. To decide why they're parallel, you need to look in your theorems and postulates of what concludes that there are parallel lines. Those are the converses, the ones that conclude that there's parallel lines. Problems, these really aren't very many problems. Well, here I guess I went 24 to 35. I thought, oh, I didn't give very many at all. These are some reviews. Okay, 4 to 10, 22. I think this starts some reviewing on 24 to 35, 60, 62 to 65. Reminder, the quiz is over 3-1, 3-2, and 3-3. And then 3-5. Those are the sections we've done so far.